Welcome back to StayAhead, Cybersecurity Auditor Mastery Series. In this episode, we are building a complete control testing work paper for communication security, specifically the network domain. This one's a hybrid engagement. We are testing both Azure AD and Azure Network plus a full on-premises network stack side by side. That's the reality for most auditors today. Nobody is pure cloud or pure legacy anymore. By the end of this video, you will have walked through all 8 audit methodology stages and 16 checkpoints, 8 design effectiveness and 8 operating effectiveness, covering the full life cycle from sampling to evidence to testing, findings and conclusion. This episode is sponsored by Audit.site, my AI powered compliance automation platform. Let's get into it. Quick roadmap before we dive in. First, we'll map this one control access across 6 frameworks: ISO 27002, SOC 2, NIST, PCI DSS, GDPR, and India's DPDP Act. So you can see how one control satisfies 6 sets of requirements at once. Second, we'll walk the 8-step audit methodology end to end against this live control. Third, we'll break down all 16 checkpoints, 8 on design, 8 on operating effectiveness. Fourth, a full evidence collection walkthrough in both Azure AD/Azure Network and on premises with mockup screenshots so you can see exactly what the evidence looks like. Fifth, we document everything in proper work paper format with sampling, results, and condition criteria, cost, consequence, recommendation, findings format. And finally, we close with the conclusion and recommendations, tying it back to framework compliance. Framework, the 8-step audit methodology. This is the backbone of every work paper in this series. So if you are new here, pay attention. Step 1 is planning. Define the control scope and pin down your criteria across ISO, SOC 2, PCI, NIST, GDPR and other standards. Step 2 is evidence collection. Documentary evidence like policies and configs, technical evidence like logs and screenshots, and interviews where needed. Step 3 is testing techniques, inquiry, observation, inspection, and reperformance. Step 4 is sampling, representative samples across normal, privileged, and terminated or edge case scenarios. Step 5 is checkpoints, at least 8 design and 8 operating effectiveness checkpoints, each one tied back to actual evidence. Step 6 is documentation, the work paper itself, recording procedures, evidence and results. Step 5 is findings, structured as condition, criteria, cost, consequence and recommendation. And step 8 is conclusion, rating the control as effective, partially effective or ineffective with framework linkage. Keep this slide in mind. Everything else in this video is just this framework applied to one real control. Stage 1, cross-framework control mapping. Let's start with the mapping. Communications security for network touches, ISO 27002, 27000, 2022 clauses, 8.20 on network security, 8.21 on security of network services, and 8.22 on segregation of networks. And on the SOC 2 side, it lines up with CC 6.1 for logical access security, CC 6.6 for restricting network access, and CC 6.7 for transmission of data. Under NIST, that's PRIR01 for protected networks, SE7 for boundary protection with SE73 access points enhancement, and AC4 for information flow enforcement. PCI DSS v4 puts this squarely under requirement 1. Network security controls, including 1.2 and 1.3 on configuration and traffic restriction, plus requirement 4 on encryption transmission. GDPR Article 32(1)(a)(b) covers security of processing, including network layer confidentiality and integrity. And DPDP Section 8 of 5 requires reasonable security safeguards to prevent unauthorized access through network channels. One control, 6 frameworks. This is exactly the kind of mapping that makes your work papers reusable across engagements. Control objectives and audit scope. Now we move into planning. Our step 1. The control objective here is threefold. Protect network communications through segmentation, secure protocols and continuous monitoring, prevent unauthorized cross-segment access and interception of data in transit, and ensure the network architecture enforces least privileged connectivity by design, not as an afterthought. Scope-wise, we are covering 3 environments: Azure AD or Entra ID, conditional access for network location controls, Azure Network, VNets, Subnets, NSGs, Azure Firewall, and Network Watcher, and on-premises perimeter firewall, VLAN segmentation, IDS, IPS, and remote access VPN. Why does this control matter so much? Because network communication security is one of the most cited control areas across ISO, PCI, and NIST. A segmentation or encryption failure here can expose every other control, including IAM, data protection, and logging, to bypass. And because this is a hybrid environment, you've got two separate technology stacks to test. You cannot just check the cloud side and call it done. Evidence collection, what to gather. Before you touch a single portal, know what you're collecting. On the documentary side, the network security policy or standard, a current network architecture diagram, the firewall or NSG rule based export, change tickets for any network or firewall changes, the VPN or remote access policy, and the wireless security standard. On the technical side, NSG rule configuration from the Azure portal or CLI. Azure Firewall rule collections, NSG flow logs from Network Watcher, and the on-prem firewall or router config export. Packet captures on sample segments, IDS, IPS alert logs, and VPN connection logs showing the MFA climb. And if you need interviews, talk to the network and infra team about how segmentation is designed and enforced. The security team about how NSG or firewall changes get approved, and IT ops about how remote access and wireless get provisioned. Testing techniques we will apply. Step 3, 4 testing techniques, and we'll use all of them in this engagement. Inquiry. Ask the network team how segmentation, firewall change approval, and remote access MFA actually work in practice. Observation. Watch a live NSG rule change move through the approval pipeline, and watch a VPN login trigger an MFA challenge in real time. Inspection. Review the NSG configs, the firewall rule-based exports, the network diagrams, and the change tickets. And reperformance. This is one auditor skip too often. Independently attempt cross-segment access yourself to confirm it's actually denied, and independently pull the flow logs to verify a sample rule. Inquiry alone never cuts it for a control this critical. Sampling strategy. For sampling, we are stratifying by network zone, production, DMZ, corporate LAN, guest Wi-Fi, and remote access VPN. The rule is at least one Azure native sample like an NSG, VNet, or subnet, and at least one on-prem sample like a VLAN or firewall zone per checkpoint. We also judgmentally include any internet phasing or PIA adjacent segment because that's higher risk by definition. And we round out the population with random sampling stratified by zone. Here's our actual sample set. S1 is the production web tier subnet in Azure sitting in the internet facing DMZ. S2 is the payments VLAN 40 on-prem, our segregated PCI zone. S3 is Corplan VLAN 10 on-prem. S4 is the guest Wi-Fi SSID, and S5 is the client VPN gateway in Azure. 5 samples per checkpoint here is for training illustration. On a live engagement, your sample size should follow AICP or ISACA attribute sampling guidance based on population size and expected deviation rate. Notice how every sample set deliberately mixes cloud native and on-prem evidence. So you see both formats side by side for every checkpoint. Design effectiveness checkpoints 1 of 2, DE1 to DE4. Let's get into the 16 checkpoints, starting with the design effectiveness. DE1 is the network segmentation policy defined. VLAN, NSD, and subnet segregation needs to be documented and approved by security leadership. E2, is there a secure protocol standard? Policy should mandate TLS 1.2 or higher and SSH version 2 and explicitly prohibit Telnet FTP, HTTP, SSL v3, and TLS 1.0 or 1.1. E3 is the firewall or NSG rule design built on least privilege. Deny by default with only explicit justified allow rules. And DE4 is the DMZ or perimeter architecture actually designed that way. Internet facing systems need to sit in an isolated DMZ, not directly on the internet LAN or VNet. Design effectiveness checkpoints 2 of 2, DE5 to DE8. Continuing the design checkpoints, E5, does remote access design require VPN plus MFA? Site to site and client VPN design should mandate MFA through Azure AD conditional access or on-prem radius. E6 is wireless security designed correctly, WPA2, enterprise or WPA3 required by design with the guest SSID architecturally segregated from the corporate network. E7 is monitoring an IDS or IPS design adequate. NSG flow logs in Azure and IDS sensors on-prem should be designed to cover all key network segments. And DE8 is there Change control design for network changes, firewall, NSD, and router rule changes need a documented approval workflow by design, not just an informal understanding. Operating effectiveness checkpoints 1 of 2, OE1 to OE4. Now the harder half, operating effectiveness. Now we prove the design actually works in practice. OE1, are NSG or firewall rules periodically reviewed? We need evidence of a quarterly rule review where unused or overly permissive rules are actually removed, not just flagged. OE2 is segmentation tested in practice. This is pre-performance. We attempt cross VLAN or cross subnet access ourselves and confirm it's actually denied. OE3 is protocol compliance verified on endpoints. A scan of sampled endpoints should confirm no deprecated protocols like Telnet, FTP, or TLS 1.0 are actually running. And OE4 is DMZ isolation verified. A sampled internet facing server needs to be confirmed as isolated from the internal network in actual practice. Operating effectiveness checkpoints. Finishing the operating effectiveness check set, OE5 to remote access logs show MFA actually enforced. Sampled VPN connection logs need to confirm the MFA challenge was genuinely completed. OE6 is wireless segregation tested. A sample test should confirm guest Wi-Fi truly cannot reach internal corporate resources. OE7 are alerts reviewed and triaged within SLA. Sample NSG flow log or IDS alerts need triage timestamps within the policy SLA. And OE8 to change tickets reconcile to the live config. Sample live firewall or NSG rules must trace back to an approved change ticket. No unauthorized rules should be found. That's all 16 checkpoints. Now let's go collect the actual evidence for these. Azure AD plus Azure Network. Time for the evidence walkthrough. We are starting on the Azure AD and Azure Network side, step by step through NSGs, Azure Firewall, Network Watcher, and conditional access. Everything you see on screen from here is a mock-up built for teaching purposes, but it mirrors exactly what you would pull from a live Azure tenant. First up, NSG inbound rules. Navigate to Azure portal, Network Security Group, select your NSG, then inbound security rules. To export programmatically, use AZ Network NSG rule list with the NSG name and resource group flags output as a table. What are you checking for? That a default deny is present, that only justified ports are open, and that there is no 0.0.0/0 exposure on management ports like RDP or SSH. Look at this rule set. Priority 100 allows HTTPS inbound from the internet. Priority 110 allows SSH only from a specific management subnet. Priority 120 denies everything else explicitly, and then platform defaults at 65,000 and 65,500 handle intranet, VNet, allow, and final deny. This screenshot or CLI export becomes your evidence for both DEP, least privilege design, and OE1 periodic rule review. Your evidence step 2, NSD flow logs, Network Watcher. NSD flow logs through Network Watcher. Enable version 2 flow logs with traffic analytics turned on. Then query the log analytics workspace using KQL against the Azure Network Analytics CL table. What matters here is confirming that denied traffic to sensitive post 3389 for RTP, 445 for SMP is actually being blocked, not just logged and ignored. In this sample flow log, you can see allowed HTTPS traffic on port 443, a denied attempt on port 3389, an allowed SSH session from management subnet, and a denied attempt on port 445. This evidence covers OE2, segmentation tested, and OE7 alerts reviewed. Azure Evidence Step 3, Azure Firewall Rule Collections. Step 3, Azure Firewall Rule Collections. Navigate to your Azure Firewall resource, then Rules of Firewall Policy, Rule Collections. Export with AZ Network Firewall, Network Rule List. The key check, does the database tier have any direct internet egress? It shouldn't, and is the default action deny in this rule collection. Web tier traffic is allowed out to Windows Update and DNS specifically, but there's an explicit deny for direct internet access from the production database VNet, and a catch-all default deny at the bottom. This is your evidence for DE4 to DMZ and perimeter design and OE4. DMZ isolation verified. Azure Evidence Step 4, Azure AD Conditional Access. Last Azure step, conditional access for network collection. In Entra ID, go to Entra ID Security, Conditional Access Policies, and inspect each policy's conditions tab, specifically locations to see the trusted versus untrusted IP ranges. The real check is whether remote or untrusted network sign-ins actually require MFA. Pull the sign-in log and test it. In our sample policy set, require MFA remote access applies to all corporate users outside the trusted network and forces MFA. Block legacy authorization blocks legacy authentication entirely from any location and require compliant device admins forces both a compliant device and MFA for global and privileged admins everywhere. This is your evidence for DE5, remote access admin design, and OE5, MFA enforcement verified. That wraps the Azure side. On-premises network. Now let's switch stacks completely and walk on the on-premises side. Perimeter firewalls, VLAN segmentation, packet capture, and IDS IPS. Same rigor, different tool set. This is exactly why hybrid audits take longer. You're really running two parallel evidence collection tracks. On-prem evidence step 1, firewall rule base export. Starting with the firewall rule base export from your firewall console, FortiGate checkpoint, whatever you are running. Go to policy and objects and export the full rule base to CSV or PDF. Cross-check the exports timestamp and hash against the approved configurations on file in your change ticket. The critical check here, can core plan reach the payments VLAN directly? It should be an explicit deny with logging on. Walk through this export with me. Rule 1, allow HTTPS to the DMZ web servers. Rule 2, explicitly deny core plan to payments VLAN 40. Rule 3, allow SSH and RDP from the IT management subset. Rule 4, deny guest Wi-Fi from reaching core plan or payments. And Rule 5 is the implicit deny all at the bottom. This evidence covers DE3 and DE4 on the design side and OE1 and OE8 on the operating side. On-prem evidence step 2, network segmentation diagram. Next, the network segmentation diagram. Get the current as build diagram from the infra or network team, Visio or Lucid Chat export, and confirm it actually matches the live switch VLAN configuration using show VLAN brief on the core switches. The important nuance here is the payments VLAN and guest Wi-Fi are isolated via ACLs at the core switch, not just relying on firewall routes further out. On our diagram, traffic flows from the internet through the perimeter firewall into DMZ VLAN 20 for web and app servers. Core plan VLAN 10 for employee workstations, payments VLAN 40 as the isolated PCI cardholder data zone, and guest Wi-Fi VLAN 30 isolated on its own. That ACL from core plan to payments VLAN 40 is an explicit deny, and we are actually going to test that in OE2. This diagram is evidence for DE1 and OE2. Next, the network segmentation diagram. Get the current as built-in diagram from the infra network team, Visio or Lucid Chat export. Step 3 is protocol verification through packet capture attached to a span or mirror port on the core switch for your sample VLAN. Then in Wireshark filter on TLS, handshake.type equals 1 to isolate client hello messages and inspect the negotiated TLS version. What you're looking for are any TLS 1.0, 1.1 or plain text protocol attempts, telnet, FTP, HTTP actually being refused. In this capture, frame 142 shows a clean TLS 1.2 client hello. Frame 143, the server hello and certificate, but frame 144 shows a deprecated TLS 1.0 client hello attempt, and frame 145 shows the connection gets an RST refused. That refusal is exactly what you want to see. This is evidence for DE2, the secure protocol standard, and OE3, the protocol compliance verified. On-prem evidence step 4, IDS IPS alert log. Last piece of on-prem evidence, the IDS or IPS alert log. Pull a CM query against your on-prem IDS or IPS data source for the sample date range and cross-check that every high severity alert has a corresponding SOC ticket with a triage timestamp. Specifically confirm that cross VLAN policy violation attempts, guests trying to reach corp, and are both detected and actually blocked, not just detected. In our sample log, an Nmap scripting engine scan gets flagged high severity and blocked. A guest VLAN to corp LAN policy violation gets flagged medium and blocked. A routine SSH login on the management subnet gets logged at low severity, and a suspicious command and control beacon gets flagged high and blocked. This log is evidence for DE7, monitoring design, and OE7, alerts reviewed and tried within SLA. That's the full evidence set, both stacks. Now let's write it up. Workpaper result, design effectiveness, expected versus actual, time to document results. This is where the workpaper earns its keep. Walking the design effectiveness table, DE1, the segmentation policy. The approved policy is on file and reviewed within the last 12 months. Pass. DE2, secure protocol standard. The standard is defined, but we found one undocumented legacy telnet exception on an on-prem device. That's an exception, not a pass. DE3, least privilege rule design, confirmed on both the Azure NSG and on-prem firewall rule base. Pass. DE4, DMZ and perimeter architecture, confirmed through Azure Firewall and the on-prem diagram. pass. DE5, remote access MFA design, conditional access and radius MFA both confirm, pass. DE6, wireless security design, confirm through the wireless controller config, pass. DE7, monitoring and IDS IPS design, Azure Flow Logs gives full coverage, but we identified one on-prem DMZ segment with a sensor gap, exception. And DE8, change control design, confirmed via the change management policy and assured, pass. So on design, 6 clean passes, 2 exceptions worth flagging. Work paper result, operating effectiveness. Now, operating effectiveness, this is where more issues tend to surface because design can look perfect on paper while execution slips. OE1 rules periodically reviewed. The Q1 2026 review was completed and 3 stale rules were removed. Pass. OE2 segmentation tested, Copland to payments VLAN 40 access was blocked, confirmed by reperformance. Pass. OE3 protocol compliance verified, one host in Corplan attempted TLS 1.0 and was correctly refused. But the host itself is still configured to offer TLS 1.0. That's an exception. Because the refusal worked, but the misconfiguration is still there. OE4 DMZ isolation verified, confirmed through Azure Firewall network rules, pass. OE5 remote access MFA enforced, 5 out of 5 sample logins show the MFA challenge completed, pass. OE6 wireless segregation tested, confirmed by sample test, pass. OE7 alerts triage within SLA, 4 out of 5 sample alerts were within SLA, but one high severity alert was triaged 12 minutes late, exception. And OE8 changes reconciled to config, 2 on-prem firewall rules were found live with no corresponding change ticket, exception. So operating effectiveness gives us 4 exceptions. Let's dig into the most serious one next. Findings, condition, criteria, cause, consequence, recommendation. Here's how you write up a finding properly using the unauthorized firewall rules as our example condition. What did we actually find? 2 on-prem firewall rules permitting traffic into the payments VLAN were found live in the rule base with no corresponding approved change ticket. Criteria, what standard does this violate? ISO 27002 2022 clause 8.32 and PCI DSS version 4 requirement 1.2. All network security control changes must follow the documented change management process. Cause, why did this happen? An emergency vendor support request was actioned directly by an on-call engineer without a retrospective change ticket ever being raised. Consequence, why does it matter? Undocumented rules increase the risk of unauthorized or unreviewed access paths into the PCI cardholder data environment. And this is a direct PCI DSS requirement of non-conformity. And recommendation, what should management do? Retroactively document and reapprove or remove the 2 rules within 5 business days. Implement automated firewall config to ticket reconciliation on a monthly basis. And reinforce emergency change retrospective approval training. That 5-part structure, condition, criteria, cause, consequence, recommendation is the gold standard for audit findings. Memorize it. Conclusion and framework lineage. So where does this leave us? Overall rating, partially effective, design is sound across both Azure AD, network and on-prem environments, but we found operating exceptions. 1 legacy protocol exposure, 1 SLA breach on alert triage, and 2 undocumented firewall rules on framework impact. ISO 27002 clause 8.20 and 8.22 a partially met and need remediation. PCI DSS version 4 requirement 1.2 is a non-conformity that must be remediated before the next assessment. And SOC 2 CC 6.6 and CC 6.7 exceptions need to be disclosed in the type 2 report if they are not remediated by period end. Here's how you would phrase the auditor's overall statement. The communication security network control is designed adequately across both environments. Operating effectiveness testing identified 3 exceptions of low to moderate severity, none indicating an active compromise. Management should remediate within 30 days and the control should be retested at the next audit cycle to confirm full operating effectiveness. That's exactly the tone and structure you want in a real conclusion, factual, proportionate, and forward looking. Management action plan. Recommendations roadmap. No work paper is complete without a remediation roadmap with real owners and real dates. P1 high priority, document or remove the 2 unauthorized on-prem firewall rules in the payments VLAN owned by the network security lead. Q in 5 business days. P2 medium, disable TLS 1.0 on the identified Copland host. IT infrastructure 15 days. Also P2 review the SOC shift over process to prevent future alert triage SLA breaches. SOC manager 15 days. P3 low extend IDS sensor coverage to the identified on-prem DMZ gap, network security lead 45 days, and also P3 automate the monthly firewall config to ticket reconciliation, network security lead 60 days. The retest plan, a full retest of OE1, OE3, OE7, OE8 is scheduled at the next quarterly audit cycle to confirm remediation and restore the control to effective status. That's how you close the loop, not just findings, but accountability under retest date. And that's the complete pattern: objective, mapping, sampling evidence, checkpoints, testing, findings, conclusion. Take this exact structure and you can turn any control into a full audit ready work paper. It doesn't have to be network security. This scales to access management, change management, encryption, anything in your framework. If this was useful, subscribe to StayAhead for the rest of the cybersecurity audit mastery series. One control, one framework mapping, one work paper at a time. This episode is sponsored by Audit.site, my AI powered GRC automation platform built to turn work papers exactly like this one into a living, continuously tested control library instead of a static document that goes stale the day you file it. Thanks for watching, and I'll see you in the next one.